In this video, I'll be working through all the questions from the summer 2025 Cambridge A-Level Maths exam paper 1-1. It'll be a long video. I don't want to just give you the solutions. I want to teach you how to do the question, and that takes time. Remember to use the chapters below in the timeline to jump to the question you're interested in. And remember, you're not in a classroom, you're on YouTube, so take advantage of their tools. Pause the video, retry a certain part of the question, rewatch difficult parts, or slow down and speed up the video as you need. With that said, let's start on question 1. In question 1, we're given this trigonometric equation that you see here, and we're also told that theta is bigger than minus 180 and less than 180. Now that's very important. It does change the answer you get. You're going to get 4 different answers for this question, and if you ignore this, you might only get 2 of them out. How do you do this question? We have something on the bottom row here, and nobody ever likes that, so we get rid of it. We multiply everyone by sine theta, so that'll disappear. The left side gets multiplied by sine theta, and we get 6 sine squared theta. The right side gets multiplied by sine theta. There's 2 things there, the 1 and this. 1 by sine theta is sine theta. 2 over sine theta multiplied by sine theta, they cancel. The sine theta is cancelled, and we're just left with a 2. Now, it might not be obvious, but what I see when I see this line is a quadratic equation. We have something squared, we have something, and we have a number. Let's put all of these together. Everything over the left hand side. 6 sine squared theta minus sine theta minus 2 equals 0. If you don't see this as a quadratic, what you could do is go ahead and replace something. Like, let's say x is equal sine theta. Really, this is just saying 6x squared minus x minus 2 equals 0. A lot of students have trouble with quadratics look like this. They find it much easier to replace something, make it look like you're used to. I will stick with this line here, okay? But go ahead and solve that. Next up, you can factorize this. There are 2 numbers that make 6 sine squared. That's something times sine and something times sine, probably 2 and 3 or 6 and 1. And then 2 numbers that multiply to get 2, well, that has to be 2 and 1. So you can just play around with the options here. 6 and 1, maybe 6 times here, 6 times 2 is 12. 12 and a 1 will appear here. Can't get to a 1. How about 1 times 2 and 1 times 6? That's 2 and 6. I can't combine that to make a 1. 2 and 3 is the answer. 2 here and 2 here, that would be 4. And 3 times 1, that would be 3. 3 and 4 can combine to get a 1. So let's go ahead with that. Let's see, 2 here and 3 here. 2 times this would be 4. That'd be 3. We need minus 4 plus 3. Minus 4 plus 3 would work. Now, if you are not good at doing factorization, which it's a bit of an art form. It's not quite something, well, I'm not good at teaching, certainly. It's something I'm good at doing, but not good at teaching. So I say to those students, feel free to use the minus b formula. We have a formula that we can put all of these numbers 6, minus 1 and minus 2 into it, and you'll get an answer out. With that said, the answer here would be sine theta is equal minus 1 over 2. Remember, this all equals 0, this equals 0. Or the other answer would be sine theta is equal 2 over 3. 2 answers there, and then we get the inverse sine, and that's where we get a problem. Theta is equal the inverse sine of minus 1 over 2. And over here, I'll just leave myself a bit of room to put an equals there. Theta is equal the inverse sine of 2 over 3. Now you could go ahead and put this in your calculator, and you should. You get an answer of minus 30 degrees. You put this one in on your calculator, and you'll get an answer of, let's see, 41.8 degrees. They are okay. They're okay answers. They're 2 of the answers they were looking for, but there's actually 4 answers. If you are finding my videos useful and would like to help the channel out,
On top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
What I'd like you to remember is whenever you do something like this, the inverse sine, your calculator is not that smart. It's not very good at doing sine. Let me draw sine out here. And continues the other way as well. This goes on forever in both ways. When you ask your calculator what you get when you get the inverse sine of minus a half, what it's doing is it's checking minus a half here, and it's only looks between, let me put a box around the world your calculator looks in. Your calculator only looks at this world and it returns the number it sees in that world, in this case minus 30 degrees. But the problem is the answer to this question actually has millions, infinite answers. All of these are perfectly valid answers. And at that point we have to check what world the examiner wanted us to look in. The calculator looked in this world. The examiner wanted us to look all the way up to this world. Let me put a bigger box in. The examiner wanted us to look all in that world. And there's this answer's outside, this answer's outside, but there's two answers inside that world. One answer is minus 30 that the calculator was able to tell us, but the other answer is over here. We have to use our brain a little. It's 30 away from 0, so it should also be 30 away. Sorry, this is minus 180. Minus 180, and that's 180. It should also be 30 away from minus 180. So the other answer is minus 150. Calculator will get us this one. We have to use our brains to get all the other ones. There might be loads of other ones. In fact, this one might not even be a correct answer. It was in this case. Similar in this one. Your calculator only checked, went to 2 over 3, got this answer here, 41.8, and that's all the calculator was able to do. We have to use our brain and say, oh, here's another answer. Here's another one. Here's another one. These are outside the world we're interested in. There's more over here. We're interested in these two, 41.8 away from 0 and 41.8 away from 180. So another answer is 180 minus this, which is, let me just check from my notes, 138.2. So that's your 4 answers, 1, 2, 3, 4. You need all 4 of those answers to get full marks in this question. And that's it for question 1. If you have any follow-up questions or you see any mistakes I made, please let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 2, they talk about a curve that goes through this point here. This is not the equation of that curve. In fact, later they ask us to find it. This is the derivative of that curve. So that's what they give us. They give us a point on the curve. Let's just draw a random curve. It really doesn't matter what it looks like. Here's a curve, and what they're telling us is here's the derivative of it, and it does have this point. What they're asking us to do then is to find the gradient of the normal of the curve at this point. So put that another way. So there's some point, let's say it's here. It has a gradient and it has a normal. A normal is just perpendicular to the gradient. If you find the gradient, you find the normal. So that's not too difficult. There's only 2 marks for this question, so there's not really, it's not trying to be difficult. The next thing to remember, and it's very important to remember, the gradient is the derivative. The derivative is the gradient. So if you're looking for the gradient of the tangent, sorry, I should say the gradient of the tangent, let's call that t. T is equal dy dx. The gradient of the tangent is this. At a certain point, when x is equal something, it'll give us every possible answer it will. At the point here, this is when x is equal to 4. So when x is equal to 4, we can find the gradient. We just put it in. This is all equal to 4. We just put x in, 4 in for x. 4 times 2 times 4 minus 5 to the power of 3 minus 9, and that's 4 to the power of a half. That's the square root of 4. Just clean all that up. Let's see, we have 2 times 4 is 8. 8 minus 5 is 3. 3 to the power of 3 is 27. 4 times 27 is 108. So obviously, do that slowly, carefully, triple check all that. The square root of 4 is 2. 2 times 9 is 18. So the gradient of the tangent is 90. What is the gradient of the normal? Well, that's it's easy to do. We turn it upside down and change the sign. So the answer they're looking for, the normal, is minus 1 over 90.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Now for part B, I'm going to guess a lot of students made a big mistake even before starting this question. Part B and part A were not related at all. In part B, they asked us to find the equation of the entire curve, not of the normal or of the tangent. I'm guessing some students thought that. How do we get the equation of a curve? This is the derivative of the curve. How do we get back to the curve itself? Differentiation got us here. What's the opposite of differentiation? Integration. If we integrate this, we get back to the curve. Basically, I want to get back to y equals, and y is equal to the integral of the derivative with respect to x. Basically, it's opposite. It destroys the derivative. So what we want to do here is integrate all of this. So let me write that out. The integral of 4 times 2x minus 5 to the power of 3 minus 9, 9x to the power of a half, and all of this is with respect to dx. This is what they're asking us to do. Integration is not too bad in some respects. It can we can do terms separately. So we have 2 terms here. We can do the first one, then the second one. Second one's not actually too bad. So let me first of all split this up. Also the 4 here, that's a constant. It can come outside. 4 times 2x minus 5 to the power of 3 with respect to x. Take away, we'll leave the 9 outside, the integral of x to the power of a half with respect to x. This again, this isn't too difficult at all. This is the one we'll concentrate on. It's not too difficult. A lot of students do it quite quickly. And you know what, let me do it slowly. Let me use substitution. I'm going to solve this part of the question, and then I'll show you how you might do it quickly if you want to. Okay, let's continue this part over here. I will use substitution. I'm going to substitute this bracket for u, or u for this bracket. U is equal to 2x minus 5. When you do substitution in integration, we need to differentiate this. Du dx is equal to. Now it's very important when the derivative is something so simple, just a scalar, just a constant, we're able to do the shortcut I'll show you in a moment. Rearrange this so x is on its own and 2 is underneath. We get dx is equal 1 over 2 du. That allows me to, instead of writing this, to instead write 4 times the integral of u cubed, and instead of dx, so I've replaced this with u, I'm replacing dx with this 1 over 2 du. And of course the 1 over 2 doesn't have to stay there, it can come out front. Let me continue this whole thing on, do it all in one go. Minus 9, let's integrate this while we're here. X, we add 1 to this power, that becomes 3 over 2, and then we divide by 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2 over 3. 3 goes in 3 times. And that's it. Let's integrate this. We'll continue up here. This becomes 4 divided by 2 becomes 2. The integral of u cubed is u to the power 4 divided by 4. And we'll write this in here. 3 times 2 is 6x 3 over 2. But remember, we made that up. Let's replace it back. Let's put it back to what it originally was. 2 and 4 go in half. That becomes 2x minus 5 to the power of 4 minus 6x 3 over 2. Now I've left something out there. I probably first should have put it in here. When you integrate and they don't give you any limits, we get a constant. So this a constant should have appeared here. Another constant should have appeared here. Two constants add together, we get a constant. So I'll just add it all in at the end here. Just be careful. Probably shouldn't do that. You probably should add. Let me add in C1 here, some small constant. C2 here plus C1 here. Two constants add together to get a constant. This is y equals all of this. Y equals all of this. You're nearly finished. You give you 4 marks. They probably give you 3 marks for this. Maybe not though, because you're missing one thing. An equation of a curve should have a y, should have an x, but it shouldn't have this c thing, this random constant. I want to know what that c is. We have everything we need to in this point. This point tells me at some point in the world, x is equal to 4 and y is equal to minus 11 over 2. So if we put that in, the only thing left will be c. We can find what c is. C doesn't change. If I find it in this one small part of the world, I find it everywhere. So let's write this out again. Instead of y, I got minus 11 over 2 equals, let's see, put 4 in. We already did that. 2 times 4 is 8. 8 minus 5 is 3. So we get, let's see, a half. We get 3 to the power of 4. Minus 6. This is a 4 in here again. 4 to the power of 3 over 2. That's the same as getting the square root of 4. That's what this divide by 2 would do. Square root of 4 is 2. 2 to the power of 3 is 8. Double check that on a calculator. 4 to the power of 3 over 2 should get 8 plus c. Let's clean this up a bit and multiply everything by 2. So on the left side we get 11. I'll multiply by 2 basically. Multiply this by 2, that disappears. We're just left with 3 to the power of 4. That's 3 by 3 by 3, which is 9 by 9, which is 81. Again, I multiplied, so 6 by 8 is, you can do all this in a calculator. 6 by 8 is 48, but I multiplied everything by 2, so I get minus 96 plus 2c. I multiplied everything by 2. Rearrange that, we get 2c is equal, let's see, we get minus 15 from these two, move that over, we get plus 15, take away 11 is 4, c is equal to 2. I ran out of room here. I might lose a mark for this. I don't know. They might give you full marks for leaving this as your answer. It's right, but what they really want to see is this line here once more. They want you to write this line out once more, but instead of having a C here, they want you to put 2. So don't lose that mark. So I've no real place to put it. I guess I could squeeze it down here in the bottom. But yeah, you can see what I mean. Write this again. Everything you see here, except for C, put in a 2. Okay, that's it for question 2. If you have any follow-up questions or you see any mistake I made, just let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 3, they tell us about a geometric progression and they give us two clues about it. The first one is that the third term is 18 and that the first 3 terms all add up to 26. They want us to use, and another clue, that the common ratio is negative. They want us to use those clues to find the 10th term in the progression. Now, most times the best way to do these questions are just to find the first term and the common ratio, and then you can find every term. So don't worry about the fact that it's the 10th term. We'll just worry about finding the first term and the ratio. Now we have a couple of formulas for geometrics, sequence and series. First one is that the nth term is equal to a times or n minus 1, and then the sum of the first n terms, let me look this one up, I'm always forgetting this, is a multiplied by 1 minus or to the power of n, so that's an n, over 1 minus or, over 1 minus or. So these are the two main equations we know about geometric progressions. Now what's interesting about this question is it was very easy to go down a wrong path that looks right. That happened to me trying to solve this, and I'm going to show you that wrong path I went down, and then I'll finally show you the correct path. What I first taught to do, and I think it is probably the right idea most times, and it does work this time, but it's just it makes it more difficult than it needs to be. So what I would have done, and what I tried to do, is I put down the first term, the third term, T3, and I put it equal to this, a times or 3 minus 1 is 2, and that is equal, we know that's equal to 18, and I use this as one of my clues. My next clue is S3. S3 is equal to a times 1 minus or to the power of 3 divided by 1 minus or, and I know that's equal to 26. This is two equations with two unknowns, a and or, a and or. So in theory we should be able to solve that. Remember, this is probably not the best path to go down. So let me do this quite quickly. I'm going to rearrange both of these so it's a equals. The first one will become a is equal to 18 divided by or squared. Then this one here will become a is equal 26, and stay where it is, multiplied by 1 minus or divided by 1 minus or cubed. These equal each other. So with this term equals this term. Let's multiply both sides by this bottom row and this bottom row. So we'd get 18, sorry if I'm going fast, but again this is the wrong path to take. 18 multiplied by 1 minus or cubed is equal 26 times 1 minus or times or squared. We can multiply all this out, we'll get 18 minus 18 or cubed is equal 26 or squared minus 26 or cubed. The or cubes go together, everything over the left, let's say. We get 8 or cubed and minus 26 or squared plus 18 equals 0. This is all correct so far, and you can solve from here. We're left with one equation, one unknown. It looks a little like a quadratic, but it's not, it's a cubic equation. They're a lot more difficult to solve. You have to just find the solution to one of them. Just find any solution. In this case, there is an easy enough solution, 1. If you fit 1 in, it does work. And then knowing that or, a possible answer for or is or equals 1, we can know or minus 1 is a factor. Use that factor to then get the other roots or the other factors to this and solve from there. That's not easy to do. This was the wrong path to take. It was a very understandable path, but it was the wrong path to take. Now let me clear most of this off and we'll start this again and I'll show you the correct path to take. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Now just to clarify, that was still a correct path to take. It wasn't a bad way to do it. There's just happens to be a lot easier, neater way to do it, and it's the way they probably intended you to. The third term is 18 and the sum of the first three terms is 26. What they probably wanted you to do was just write out the first three terms. A plus A or, that's the second term, plus A or squared. And the fact that they all added together is equal 26. And just like previously, we still know the third term, AR squared, is equal 18. This time, this is our two clues we're going to put together to get the answer. Oh, I should note, there's also another wrong path you could take here. You could have attempted, instead of writing this term, you could have put 18 here. The problem with that is you've combined these two equations, and we still would have two unknowns, A and AR. So that would be the wrong path straight away. Now we combine this just like we did previous. I'll rewrite this one here as A multiplied by 1 plus or squared is equal to 26. So we can rewrite that as A is equal 26 over 1 plus or squared. And just like previously, this one could be rewrote as A is equal 18 over or squared. We're going to put these two together. Let me write them out first actually. 18 over or squared is equal 26 over 1 plus or squared. Now what's much better about this way than previous? What's better is when we cross multiply here, we're only going to get or squared. Last time we ended up with or cubed, and that's what caused us a little bit of difficulty. So let's go ahead and cross multiply. 18 times this is 18 plus 18 or plus 18 or squared. Or squared by that is 26 or squared. Let's get everything the same side with a positive or squared. So that's 8 or squared minus 18 or minus 18 equals 0. We've got ourselves down to a quadratic. Now everything divides by 2, so let's get that down again. 4or squared minus 9or minus 9 is equal 0. We can go ahead and factorize this. It does work out quite evenly, but if you are not good at factorizing, feel free to use the minus b formula. Go ahead and do that. But this two numbers to make 9 could be 9 and 1 or 3 and 3. Could be 2 and 2 or 4 and 1. I've actually forgotten which it is. Let's see, 4 times 3 would get 12, and then 1 times 3 would get 3. 3 and 12 does go together to get 9, so that's it. 4 or, and 3 and 3. Let's see, we want minus 12 plus 3. So that'd be minus 12 plus 3. Our two answers here would be or is equal minus 3 over 4, and or is equal to 3. Now I just want to point out, if you had have completed that cubic equation I got earlier, we would have got these same two answers, but we would have also got or is equal to 1 as another answer. But ultimately they told us that the or was negative. So these two answers, this one would only appear if you had have got that cubic, solved that cubic equation. But this is not the answer we want. This is not the answer we want. This is the answer they want for part A. I just realized that's not the answer to part A. They wanted the 10th term. This is simply what or is. We still need to get what A is. A is either of these. This is 18 divided by or squared. Minus by minus is a plus. 3 by 3 is 9. And 4 by 4 is 16. That's the same as 18 times 16 over 9. 9 goes into 18 2 times. This is 32. A is 32. So the 10th term, T10, is equal to, let's see, A, which is 32, times or, which is minus 3 over 4, to the power of 10 minus 1. That's 9. You can go ahead and put all of that into a calculator, and we get 2.4, or sorry, minus 2.40. Now it might surprise you to see a minus there, so you might want to double check where that came from. The ratio was a minus. So the first term was 32. The second term is 32 divided by 4, which is 8, multiplied by 3 is 24, but a minus. So it's actually minus 24. The next term we know is 18, and instead of going on like this, we're going to get minus a plus, and that's how we end up with a minus term. Actually all the even ones, the second, the fourth, and in fact the 10th term will all be minus. Okay, let me clear the board off and we'll do part B. In part B they ask us to find the sum of infinity of the whole progression. So we have a formula for that. The sum to infinity is equal a divided by 1 minus or you can actually get that from this quite easily. The sum to infinity only works when or is less than 1, or the absolute value of or is less than 1. So if you think of something to the power of infinity, or it multiplies by itself so much, anything less than 1 multiplying by itself is going to get smaller and smaller. Ultimately that will end up at 0. So just a times 1 is a 1 over or on the bottom row. Okay, so we just fill these numbers in. This is equal to 32 divided by 1 minus 3 over 4. That bottom row becomes 1 plus 3 over 4. Let's do it all there. That becomes 1 is just 4 over 4 plus 3 over 4. That's 32 7 over 4, or 4 over 7 multiplied by. That doesn't go in evenly, so that just becomes 128 divided by 7, and that's they wanted an exact answer, so that's our exact answer for the sum of infinity of this progression. And that's it for question 3. If you have any follow-up questions for me, please let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 4, we're given two equations, one that makes this curve and one that makes the line. And we can see that represented here. And they've shaded in the region between these curves. And they want us to find the area of that shaded in region. What's more, they've also told us that the point of intersection here, or the x part of the point of intersection, is 1 and 16. That's enough information for us to get this area. When you see a curve and area, you should be thinking integration. And that's exactly what we're going to do here. We have a couple of choices how to do this question, or it's more what order we do certain things. We can, and I often recommend it, it's not how I'm going to do it, but we can split this question up into two parts. And I'll draw that out here quite quickly. We could just get the curve first of all and integrate that. When we integrate something, we get the area between it and the x-axis. With one wrinkle, it's positive when we get it above the axis, it's negative when we get it below. So in this case, if we integrate this top row here, this yx to the power of 3 over 2, we're actually going to get a minus number. So if we did that separately, it'd be fine. We just might want to change it to a positive before we move on. And again, next we can take a couple of paths doing the next one. Sorry, this is between here we'd be getting. In this case, it would look like this. That's a triangle, but we can still integrate this. If you integrated this between these 2 points, 1 and 16, you'd get the area. Again, you just get a minus number. So what we could do is take this positive number, take away this positive one. If we change them both to positive, we'd get our final answer. That would work. The next thing you could do is just work out this triangle. It's 15 long. It's how could we get its height? If we put 1 into this, 1 minus 16 is minus 15. So this number down here is actually minus 15. So I haven't drawn, or they certainly haven't either. They've not drawn this to scale. So this is actually just 15 times 15 divided by 2, I guess, is its area. But what we're going to do is we're going to combine this. We're going to do this all in one. Instead of getting the area of one, take away the area of the other. We're going to take them away before we integrate. And this is quite a common thing to do. To get the area between two curves, we integrate the top curve minus the bottom curve. In this case, the top curve would be this line, the bottom curve would be this one. If we integrate the top one, which is x minus 16, let's put a bracket around it, minus the bottom one, 5x to the power of 3 over 2 minus 20x, put a bracket around it because this minus and this minus is going to interact. If we integrate all of this with respect to the x, this will just give us the area out. We actually don't have to worry about the plus and the minus. This will always sort it out for us. and this is between 1 and 16. But what we're actually doing is we're getting the area of this one, the bottom one, which will actually come out as a minus. The area of this triangle, this is going to be. And then we're going to get the area of this one, that'll be this one. That'll be a minus number already, and we're going to take it away. So minus a minus number. This is going to become a plus. This is going to be a minus, so we're going to get this, take away this shape, and we're left with the area we're looking for. Okay, let's go ahead and do that. These are just 4 terms. You can just integrate all 4 terms. But there is a bit of a shortcut. We have an x minus 20x, so that's actually 21x. Let's clean this up and we'll rub this out and start it over here. And this becomes, let's see, the highest term would be minus 5x 3 over 2 plus 21x minus 16. So this is what we have to integrate. Let me clear off these 2 drawings, and hopefully we can fit it all in here on the right.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Okay, we just have 3 terms to integrate. The first term, x to the power 3 over 2. That becomes x to the power 5 over 2. We're just adding 1 onto this. Looks like I added 2, but 1 onto this would be 2 over 2. So 2 over 2 onto 3 over 2 is 5 over 2. This has a minus 5 in front, and we divide by 5 over 2. The 5's will cancel and the 2 will become a multiply. I'll fix that next time. Next term we have 21x. That becomes x squared. The 21 is out front, divided by this 2 now. That'll be a plus. And next term, the 16, that becomes a 16x. And all of this is going to be evaluated between 16 and 1. That was still 16 and 1. We can start cleaning this up a lot. Let's see, this becomes minus 2. That's we're dividing by 2. That's the same as multiply. So minus 2x to the power 5 over 2 plus 21 over 2x squared. All these are fine. And we just have to fill these numbers in. So this is going to take a bit of work. I'll write it all out here and then we'll let our calculator do the work. This is going to be minus 2 times 16 to the power 5 over 2 plus 21 over 2 times 16 squared minus 16 times 16. Then we're going to take away putting 1 in. So we get minus 2 plus 2. 1 to the power of 5 over 2 is just 1. 1 squared is just 1. So this becomes minus 21 over 2. Minus 16 becomes plus 16 times 1. And we just put all this into a calculator. Of course, be careful, do it multiple times, make sure, check over your work. I get 783 over 2. If you divide that in, that's the same as 391.5. Like I said, there was other ways you could do that. You could have just got the 2 shapes. Let me draw that one last time. This shape, that would work out. I did the area out here. That area works out as 504, or indeed minus 504. And then the area of the triangle. So again, this is this area here. The area of the triangle works out to be 225 over 2. Again, if you integrate that on its own, you'd get a minus. But so you could say 504 is the area of this. Take away 225 over 2 leaves you this area here. Because this is, let's say, 1008. Take away 225. Yeah, I think it looks about right. It's within 1 or 2 of being right anyway. Okay, that's it for question 4. If you have any follow-up questions for me, let me know in the comments and I'll do my best to get back to you. Thanks for watching. Have a great day. In question 5, part A, they give us two expressions and they want us to expand both of them. We do them both pretty much the same way. We're going to use the binomial expansion. That's something we can use when we have two terms adding together. So that's the first thing I'm going to change to this. I tend to do this all the time. 2 plus minus px. Let's put a little bracket around that, just to make it clear it's its own thing. We have one thing on the left, one thing on the let's put a bracket around this one on the right. Now we have a formula for this when it's a plus b to the power of n, and we expand it out. I'm just looking at the formula. Yeah, so in the formula we always start with this one to the power of n, or to the power of 5. That's going to work out fine in this case. They could have been tricky and put one of the x's on the left. That would have confused people. The binomial expansion is perfectly symmetrical. You could work it either way. How I don't even look at it usually. I remember it like this. You can expand these two terms out by taking either one, whichever one you want to start with, one of them to the power of 5 and the other to the power of 0. Then to the power of 4 and 1, 3 and 2, 2 and 3, 1 and 4, and 0 and 5. That's how I think of it, with just one or two little tweaks in between. So what do we want? We want the three ascending terms of x. So that means we want x to the power 0, or no x's, x to the power 1, or just x, and x to the power of 2. And that's it. We want to stop there. So what we want to get is we want to get 2 to the power of 5 multiplied by, I'll write it in. This is not what the formula says in your tables. Minus p to the power of x to the power of 0. It doesn't have that in your tables because it doesn't need it. That's just 1. That just goes away to 1. So we're left 2 to the power of 5. Next term, I'll leave a bit of room because I'm going to cheat a little. We want 2 to the power of 4 and minus p x to the power of 1. The next term, we're going to have 2 to the power of 3 and minus p x to the power of 2. Next term we don't care about. They only ask for the first 3. Now I've missed something here. In fact, I've left it off here because again the tables does. This has n choose 1, or in this case 5 choose 1. This would be 5 choose 0, which is actually just 1, so we don't bother writing it. 5 choose 1, and this would be 5 choose 2. And if we did need any more, it'd be 5 choose 3, and so on. We can clean all these up. This first one, like I said, that's 1. That's 1. We're just left 2 to the power of 5, which is 8 times 2 times another 2 is 32. This becomes 5 choose 1 is 5. 2 to the power of 4 is 16. And minus, we just get a minus there. P and x. I don't know why I wrote it like that. I'll fix it up in a moment. Next, 5 choose 2. That's just 10. 2 to the power of 3 is 8, and minus px squared. Two minuses will make a plus. P times p will make p squared, and x times x will get x squared. And this continues on. Let's actually clean it up properly this time. 32. 5 times 16 is 80, and minus 80. There's a p there as well, and we have an x. This one we have 80 as well. Yeah, plus 80 this time. P squared, x squared. They're the first 3 terms of that expansion. Let's do the next one then while we're here. We'll skip a line or two on that one though. We have 1 plus minus x over 2. I've just changed that ever so slightly to the power of 4. So once again, we have the first term to the power of 4. That's 1 to the power of 4. Plus 1 to the power of 3 times minus x over 2 to the power of 1, and that's 4 choose 1. And then we have 4 choose 2, 1 to the power of 2, and minus x over 2 to the power of 2. Clean this up, we get 1 here. 4 choose 1 is 4. 4 times 1 is 4. We have a 2 on the bottom row, so 4 divided by 2 is 2. We have a minus comes out of that. And we have an x, so minus 2x. 4 choose 2, that's 6. We have 1 here, we have 2 2's in the bottom row. So that's 6 divided by by 4. Well, let's get the signs first. We have a plus and 2 minuses, so we get a plus. Number, we have 6 on the top row, we have 4 on the bottom row. That goes in 3 over 2. And we have an x squared here. There's no p's on the second one, no. Okay, x squared. And this continues on. We just don't care about it. And that's it. That's these two expanded out into their first 3 terms. And that's all they asked you for part A. That's these two expanded out in their first 3 terms. We're going to need them for part B, so I'll clear all this off, but I'll write these again up the top.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Okay, in part B, they give us this expression here, this term to the power of 5 multiplied by this term to the power of 4. This would be an absolute mess that would take you like 10-15 minutes to do the entire thing out. It would take an entire page and you're bound to make a mistake in it. But they only ask us about the x squared coefficient in it. They're talking about that. So obviously what we do is we use what we learned in the first part. So instead of this, let me write out this massive multiplication here. Let me just go to my notes. So first part, this guy expanded out to 32 minus 80px plus 80p squared x squared plus like loads more we didn't even bother with. And the second one expanded out to be 1 minus 2x plus 3 over 2 x squared, and again loads we don't even care about. What they're really telling us is that when we multiply all of this out, somewhere in that mess we will get a 93 x squared. In fact, that's the only x squares we'll get is this, they'll all add up to this. So what they're asking us to do is not multiply all of this out. They're asking us to find how we would get x squares. For example, 32 will end up multiplying by 1. I don't care because there's no x squared in it. Also, 32 will multiply by some x to the power of 4 down here. I don't care because it doesn't have x squared. So which one will I care about? I will care about 32 multiplying by this x squared. I will also care about this x multiplying by this x. That will make an x squared. I will also care about this x squared multiplying by this number. That will make an x squared. And I know all 3 of them are going to add together to equal 93. So let's do that out. 32 multiplied by 3 over 2 times x squared. Then we'll have minus 80p times minus 2x. 2 minuses will make a plus. 80p times 2 x by x will make x squared. And then finally we'll have this multiplied by that, which just comes out as 80p squared x squared. Get rid of all the x squares. We're only interested in the numbers in front of the x squares. Or if you'd rather, just think of it as dividing across by x squared. They're all gone. In fact, I wouldn't have bothered to write them out, except I was trying to show them. Let's see, we can cancel some things in. That goes in 16 times. Yeah, we can clean this up. 3 times 16 is 48 plus 160p plus 80p squared, and I know that equals 93. We've got a quadratic equation here. Let's clean it up. We have 80p squared plus 160p, and this comes over here. We'll get 48 take away 93 is, let me just check my notes, is minus 45. Minus 45 equals 0. Okay, so things go into this. 5 at least goes into everything. Let's see, 5 goes into that 16 times. 16p squared. So therefore it goes into this 32 times. And it goes into this 9 times. I don't think anything else goes into all of them. This you can factorize. It's something we can factorize. But if you're not good at factorization, this is even harder because there's a lot of big numbers here. So go ahead and use the minus b formula. But I will try to factorize. Let's see, we could have 4 by 4 and 3 by 3 and maybe a solution. The largest thing we can get from that would be 4 times 3 is 12, and another 12 would get us up to 24, so that's not good enough. How about 4 by 4 and 9 by 1? 4 by 9 would get us to 36, that's within the range. And then the other part will get us a 4. 36 minus 4 does get to 32, so that does seem the answer. So 4p by 4p and 9, let's see, put it, oh, it doesn't matter. 9 here and 1 here. Let's see, we want plus 36, then take away 4. So we'd get that. The two answers, do we want two answers? Yeah, possible values. That's always a clue. They said they had a plural there. The answer to this would be p is equal 1 over 4. Because remember, this is equal 0. And the answer to this would be p is equal minus 9 over 4. There are two answers, two possible values for p. And that's it for question 5. If you have any follow-up questions or you see any mistakes I made, let me know in the comments please, and I'll do my best to get back to you. Thanks for watching and have a great day. In question 6, they give us two equations. One, an equation of a curve, and another equation of a line. But they're both missing some information. K is missing here and P is missing here. In part A of the question, they tell us K and P. They tell us K is actually 2 and P is, what's that? It's 11. So we can put that in. They'll change it again in a moment. And what they want to do is they want to find the coordinates of the point of intersection between the curve and the line. I've no idea what this curve looks like. I'll just draw a generic curve here. And a line, again, I have no idea. It might hit 3 times, 1 time, 2 times, no times. Although it does hit it because they told you to find them. And indeed, part B is a case where it doesn't hit the curve whatsoever. Okay, how do you find points of intersection? We've two equations, two unknowns, x's and y's are all that's here. We should be able to put this together and solve it. The second equation already is set up to be y equals, and y is on its own. So what we do here is we rewrite the first equation, 2x squared minus 2x, but instead of y, I put in this here. I put in 11x plus 3, still plus 2, still equals 0. We've now replaced all the y's in this equation. So this is one equation, one unknown. We can solve that. Let's clean it up. We'll have 2x squared and minus 2 times 11, 22, x times x is x squared, minus 6x, that's minus 2 times 3, plus 2 equals 0. Hopefully you're seeing quadratic here. We have multiple x squares though, let's put them together. Minus 20x squared minus 6x plus 2 equals 0. We could change the sign of everything, and everything divides by 2. So let's do that. Or you could just say divide by minus 2. That becomes 10x squared. This becomes, plus 3x and minus 2 equals 0. Minus 1 equals 0. Now this is a quadratic. You can factorize this. Well, you can in this case factorize it. If you're not good at factorization, use the minus b formula. But in this case, there's only one way to get to 1. That's 1 times 1. So there's a good few options for this though. But ultimately we need to get to 3x. So you could try 10 and 1. It's not going to work. 5 and 2 will work. 5 times 1 is a 5. 2 times 1 is a 2. So 5 and 2 do combine to get 3. So doesn't matter which way we put them. 5x, 2x. If we have plus 5x minus 2x, we'll get plus 3x. So the answers here, let's do it over here. The answer there, this is equal 0. So we'd have x is equal, let's do this one slowly. I'm always doing these too quick. 5x minus 1 equals 0. That's 5x is equal 1, and that's x is equal 1 over 5. The other one, I'll do this one fast though. x is equal, move this over to equals, so minus 1, and divide by this 2. It's minus a half. That is not going to get you full marks. They wanted the points of intersection, the coordinates of the points of intersection. This is only the x coordinates. They still want the y coordinates. Let's split the world up here. When x is 1 over 5, y is still equal to this. Y is equal 11 times 1 over 5 plus 3. Instead of 3, let's write that as 15 over 5. So we have 11 plus 15, that's 26 over 5. And similar one down here, y is equal to, 11 multiplied by minus 1 over 2 plus, let's write 3 is 6 over 2. That's minus 11 plus 6, so that's minus 5 over 2. Sorry, that's minus 5 over 2. So the points are these 2 points put together. You get full marks already here, I think. I like to just write them down together. 1 over 5 and 26 over 5 is one of the points, and the other point is minus a half and minus 5 over 2. That's your 2 points of intersection.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
For part B, I've put the k and the p back in the equation because we're not dealing with the same numbers before, so I wanted to make that clear. But they did tell us what p was. It's not, I think it was 2 in the first time, it's actually 4 this time. But they do not tell us what k is this time. What they do tell us is that they ask us to find the values for k so that these do not intersect. Now to do that is pretty much the same as finding the values for when they do intersect. You just try and do it, and hopefully you find some error you can take advantage of. Thinking about what we just did before, we put it together and we found a quadratic equation. So I hope some alarm bells are ringing off in your head for quadratic equation and does not intersect. I guess we'll talk more about it when we get there, but that's what I'm already thinking at this point. I'm thinking of that path ahead. But let's continue the same ways we did before, and then I'll show you more when we get there. So what we did before, we put this equation into this. Problem here is we have 3 unknowns. So that might stop a few people. Put this one into this. We get 2x squared minus kx. Instead of y, we get 4x plus 3 plus 2 equals 0. Multiply this out, we get 2x squared minus 4k x squared minus 3kx plus 2 equals 0. This is not as clearly a quadratic, but we do have x squares, x, and a 2. Let me group this together. I think it will help a lot of people. Group the 2 x squares together. So let's put the bracket out front. We would have a 2 and a minus 4k. This is identical to this. The x's here would have a minus 3k x plus 2 equals 0. Okay, if we know there's no answer to this, but this would give us an answer. So what's going on? Well, a quadratic doesn't always have an answer. How we solve a quadratic equation, except for the simple ones that can be factorized, is we use the minus b formula. Let me write out the whole thing. X will equal minus b plus or minus the square root b squared minus 4ac all over 2a. There is a set of circumstances whereas this does not have a solution. Now hopefully you see it, although of course it does have a solution in complex numbers, but we're not in complex numbers. Actually, complex numbers is an in-paper one, so you're fine on that as well. This square root here, that can never be a minus number. If that's a minus number, there will be no real solution. And this, we're in a real case here. We're talking about curve and a line intersecting. They will not intersect if what's in here is a minus number. So what we know from this piece of information is that b squared minus 4ac is less than 0. This is something quite common. When it equals 0, there's only one solution. When it's greater than 0, there's two solutions. That's the most normal case. And when it's less than 0, there's no solution. Have a look what a, b and c are. Here's a, it's everything in front of the x squared. Here's b and here's c. Just be careful with b. B is minus 3k. A is 2 minus 4k. We fill all them in and see what we get. B squared is minus 3k squared. That's minus by minus plus 3 by 3 is 9. K by k is k squared. Let's do this one slower. Minus 4 times a. A is 2 minus 4k. And c is a 2. All this equals 0. Let's multiply this out. We get 9k squared minus 8 plus 16k. Oh, I'm sorry. All of that was multiplied by 2. Let's put a bracket around it there. Yeah, let me just do one extra line. Apologies for, I should have done all that in one go. K squared, we get minus 16 plus 32k is less than 0. Let's rearrange this. So it's 9k squared plus 32k minus 16 is less than 0. Now what we have here is obviously a quadratic, but it's an inequality. These are a bit more difficult to solve. There's a couple of ways to do it. You can factorize it as we normally would, which works out fine here, and then look at the possibilities. So to make this is a minus number. Less than 0 is a minus number. So the two factors must be plus and a minus. We can do it that way. It's not my favorite way. The best way I think to do this is to draw a picture. Drawing a picture of a quadratic, just roughly, we know this is a positive number here. So the quadratic will be a smiley face, I think of it. We also know it's minus 16 is a y-intercept, so it must be below here. So it must look something like this. Maybe it's over to the right or to the left, not sure, but it must look something roughly like this. So what this is telling us is, when is this less than 0? So that's between this point and this point. Between these two, it's less than 0. So forget about the inequality. All I really want to know is what are these 2 points? And that's just solving a normal quadratic. If I change that to an equals, if I just solve this normally and then work from my picture, I can answer it. To solve this normally, we probably should use the minus b formula, because not every student will be able to solve this. But so yeah, I'm not going to spend my time going through the minus b formula. You can do that yourself. You are able to factorize it. Let's see, to get to 32, we need a pretty big number. So how about 9 multiplied by 16? That's way too big. And 9 times 4, we'll get very close. You'll get to 36. 9 times 4 would leave 1 times 4, and that will get to 32. So that's 9k times a 4 here. That would leave a k and a 4 here. That would be, we want plus 36, take away a 4, and that'll solve all that. So we'll have k is equal 4 over 9, or k is equal minus 4. Remember, our picture might not look too well, but basically we have, this is the smaller number. That must be the minus 4. That's the biggest number, bigger number, 4 over 9. So the answer to this, going back to the inequality, the answer is everywhere between these two. So I'd write that like when k is bigger than minus 4, or let me just put a line there, is when it's bigger than minus 4 and when it's less than 4 over 9. That's the answer to that question. Like I said, there was a couple of other options. You could have factorized this and said to yourself, well, this has to be bigger than 0 and this one has to be less than 0, and solve that, see what that tells you. Or another possibility is this is less than 0 and this is bigger than 0. See what the possibilities of that are. You should get the same. You might get them out as two different equations, but you should get this is bigger than that, that's less than that. Okay, that's it for question 6. If you have any follow-up questions, about like how to solve this or anything else, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 7, they tell us about a curve that has this equation here. And then they talk about a point moving along. Let me draw just a random curve. It really doesn't matter what it looks like. They're talking about a point moving along this curve. And they tell us that its y coordinate is decreasing 5 units every second. Now, what does that mean? What they want you to take from that sentence is, they want you to turn that English sentence into maths. And what that English sentence is, it says that y is changing. It says the delta of y, dy, y is changing with respect to time. It says every second. That means with respect to time, time is changing. And it's telling you that change is equal to 5 decreasing, so minus 5. That's what they want you to take from that English sentence. Comes up most years, an English sentence, something like that, has to be turned into maths. Next, they ask you to find the rate at which the x coordinate is changing. Now the word there, rate, is important. Rate means with respect to time. So they want you to find dx dt. That's what they're looking for ultimately. How do you go about this? The main thing you need to notice here is, well, you have y. So you're able to find, let's do it down here, you're able to find dy dx. So that's what they really want. And you can combine both of these together to find it. Both of this and this one together to find this one. That's the trick to this question. So the first thing you're intended to do here is to find dy dx. There's y. Anytime I'm trying to find dy dx or differentiate, I like to change it so it looks standard. Instead of over x squared, I would change that to x to the power of minus 2. I also do that with square roots. Change the square root to the power of a half. Because differentiating this should be quite easy. The derivative of this is 2 multiplied by 4 is 8, and take 1 away from the x squared, which is x to the power 1. Here, minus 2 times 9 is minus 18, and take 1 away from that, we get minus 3. The derivative of minus 8 is 0. That's dy dx there. Now remember, what we're looking for is this one here. To do this, we're going to use the chain rule. I think the easiest way to think of the chain rule is just like this. dx dt is the same as dx dt. If only we put something here. You can put anything here, because imagine this is dividing itself. This is like 8 divided by 8. It doesn't matter, it's only 1. In this case, so you can put anything here. So why not just put dy and dy? They'll cancel. This is clearly the same. But look, we know what dy dt is. It's right here. And dx dy, it's very similar to this. It's just that upside down. So this is actually equal, this upside down, which is 1 over 8x minus 18 over x to the power of 3, multiplied by dy dt, multiplied by minus 5. So we just put that up here, we will, minus 5. You're pretty much finished. This is the rate of change of x. Is this at every moment of x? You tell me what x is, I'll tell you what the rate of change is. And they did tell us what x is. They told us x is equal to 2. So let's do it over here. dx dt when x is equal to 2 is just all of this here. It's minus 5. Let me clear that off first. It's just minus 5 divided by 8 multiplied by, it is plus 2, isn't it? 8 multiplied by 2, which is 16, minus 18 divided by 2 cubed, that's 8. Use a calculator, we'll solve that for you quickly, or do it yourself by multiplying by 8. Everyone by 8, top row becomes minus 40. 16 times 8 is, what is that? That's 80, and 3 8s are 24, so 6 8s are 48. 80 plus 48 is 128. Yeah, minus 18. This is equal, 128 minus 18 is 110. minus 40 over 110. 2 goes into both of them at least anyway. So minus 20, 55. Oh, sorry, 10 went into both of them. What am I thinking? This is equal to minus 4 over 11. And that's, let me just double check my answer. Yeah, that's the final answer to part A. Let me clear this off and we'll do part B.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
In part B, they ask you to find the coordinates of the stationary points of the curve and determine their nature. Right, to do that, to find the stationary points, first of all, we just need to find dy dx, which we already have here, and put it equal to 0. So we're going to need dy dx. To determine its nature, well, there's a couple of, you could just start drawing pictures and make assumptions about certain things, but the easiest way to determine whether it's a maximum or a minimum or a point of inflection is just to find the second derivative. So it's in the wrong order, but let me put the second derivative here. That the second derivative is equal, just this differentiate. This becomes 8, 1 multiplied by 8. This becomes minus 3 times 8d and is plus 54 times x to the minus 4. That's the second derivative. We can use both of those pieces of information to find these stationary coordinates. First of all, let's put this one equal to 0. So that's 8x minus 18 over x cubed is equal to 0. And we solve this. It's one equation with one unknown. We should be able to do it. First thing we do is multiply everyone by x cubed. Multiply this by x cubed, it disappears. Multiply this by x cubed, it becomes x to the power 4. 0 by anything is 0. So we just saw this. We get x to the power 4 is equal 18 divided by 8, or that's the same as, let's see, 9 divided by 4. So we just need this to the power of 1 over 4. It doesn't go in fully evenly, but let me write it like this. X squared would be the square root of both these. Is plus or minus, this would be 3 and this would be 2. The plus or minus appears when we, not when we take the square root, but if something's squared, this is x to the power 4 is x squared squared. So this plus or minus this squared would get this. So that's where the plus or minus comes in. We take square root again, as it were. Another plus or minus appears, I guess, but there's only so many plus or minus, so it's still just plus or minus. Plus or minus square root of all this, so 3 over 2. That's your two, so there's two answers, and they're both stationary points. They wanted the coordinates, so you need to find y. And y, let's put it up here. We have an equation with, this equation here with y. Let's put each of them in separately. First of all, let's do the plus one. Y is equal to 4 times this squared. Well, we had that just here. That's whether plus or minus squared, we get a plus. So we get 3 over 2. Plus 9 times divided by this squared, which again is the plus part of this, 3 over 2 minus 8. I said I was just doing the plus part, but the plus or minus has disappeared because they're both square. They both got squared out. The plus and the minus part will be identical. I don't have to do the minus part. Hopefully that's clear. You can do it again if it's not clear. See, 4 divided by 2, this becomes 6. Turn this upside down and multiply it. 3 goes in 3 times, that's a 6. And that's minus 8. That's 12 minus 8. That's 4. If you want to do it again as a minus, you will still get 4. Minus this squared is still a plus 3 over 2. You'll get identical. Plus 9 minus this squared is still 3 over 2. Nothing changes. You'll get y equals 4 again. So the two answers you get here are square root of 3 over 2 and 4. That's 1 point. And minus the square root of 3 over 2 and 4 is the other point. They're the 2 points you get from this. The only thing left to do is to determine their nature, meaning are they a maximum or a minimum, because we know they're stationary points. So how do we do that? We simply put the x part into the second derivative. Well, the second derivative's has x, so we put the x into it. Luckily we have, let's write that as divided by x to the power 4. Remember, we do have x to the power 4 here. We know it's 9 over 4, so this should be quite easy to do. Let's do it over here. The second derivative is equal to 8 plus 54 over 9 over 4. And once again, this is the same whether it's a plus or a minus. A plus or a minus to the power of 4 is still a plus. If it's a plus, it's plus by plus by plus by plus, which is a plus. If it's a minus, it's minus by minus by minus by minus. 4 minuses make a plus. Either way, this is a plus. We don't even have to multiply this out, in fact. Well, let me continue on. This is 4 over 9. 9 goes into that 6 times. This is 8 plus 24, which is equal to 32. 32 is bigger than 0. But I knew already, hell, from this one here, I know it's bigger than 0. 8 is bigger than 0. 54 is bigger than 0. And x, anything to the power of 4 is bigger than 0. This all has to be bigger than 0, no matter what we put in here. So, if the second derivative is bigger than 0, that has to be a minimum. That has to be a minimum. And that's the answer to question 7. If you have any follow-up questions about anything there or in part A, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 8, we're given the equation of a circle and an equation of a line, and we're told that they intersect at 2 points, those points being P and Q. We're then asked to find the area of a triangle that's formed from the tangents at those 2 points. That's very hard to understand from listening to it and even from reading it, so let's try and draw it out. The line isn't too hard to draw. It's a straight line going straight down. That's actually going to be important, the fact that it goes straight down. The circle, we know a little about it, so we can tell which side of the line it's on. We know half this number and half this number, change the signs, gives us the centre. That's 3 and minus 5. The line's at minus 2, so the centre of the circle must be to the right of it. So we'll just put it somewhere like this, and we will try and draw a circle roughly correctly like that. So here are the 2 points. Let's call these P and a Q, like we were asked. And they told us about a triangle formed by the tangents. So the tangent of this would go something like that, and the tangent of this would go something like that there. And this would form a triangle. And we can see the triangle here. This is the triangle we're talking about. Now, a question like this is quite common. We have a circle, we have tangents to the circle. It's quite common to be asked to find this point out here. And to find the area of the triangle, we could just find this point and work it out from there. This question is a bit more interesting in there's a few shortcuts. There is a few shortcuts to answer this question. I'm not going to use them at first. So if you want to skip ahead in the video, there's a really short way to do this question. Using just angles and similar triangles. I think it's a very clever way. I'll do that later in the video. First, I'm going to do it a slower way, although I'll still take a couple of shortcuts here and there and point out where there's a few extra shortcuts. All these shortcuts come about because of how flat things are. This is a straight line down, and just to spoil some of the shortcuts, the line that goes from here to here, it's also flat. It's parallel to the x-axis, and this is a 90-degree turn here. There's a lot of tricks like that. Actually, let's fill in a few other things here. There's a 90-degree angle there. That's very important for the really fast way. Okay, so the slower way to do this, a way that you'll probably do in a lot of questions, is to try and find at this point by getting the equation of both of these lines. So let's do, first let's find this point. Yes sir, we don't even have these points. They're quite easy to find. We put these two equations together, which sounds difficult, but this one's so simple. It's x is minus 2. We just put it in everywhere up there. So this becomes minus 2 squared, which is 4. Y squared doesn't change. Minus 6x. 6 times minus 6 times minus 2 is plus 12. Plus 10y doesn't change. Minus 27 doesn't change. We have a quadratic equation in y here if we clean it up. Y squared plus 10y. We have minus 27 plus 12 plus 4. That comes out at minus 11. It's a quadratic equation. However you want to solve them, use the minus b formula, but this one is factorizable without too much difficulty. Y by y makes y squared. The only way to get 11 is 11 times 1, and that does in fact get to 10. We have plus 11, take away 1, we'll get to plus 10. So the solution here is y is equal to plus 1 or y is equal to minus 11. So these 2 points, and we should have known one of the points was already minus 2. The other point is 1, the higher number. And this one down here would be minus 2 and minus 11. And we also know the centre. That's 3 and, minus 5 is the centre. So how do we find the equation? I'll find the equation of this line here, and I'll do all the work to find this one, then I'll just show you the answer to this one because it's the same. So to find the equation of this line, we need the slope of that line and we need a point. We have the point, that's fine. So we really just need the slope of this line. That's where it's important to realise that this is a right angle here. That the tangent to a circle, the normal of the tangent goes through the centre. This is a right angle. If we find the slope of this line, we turn it upside down, change the sign, we have the slope of this line. So let's get the slope of this one. That would be 1, this 1 here, take away this minus 5. So minus 5 is plus 5. Over minus 2, that's this minus 2, take away this 3. Minus 3. That becomes 6 over minus 5, or minus 6 over 5. Turn that upside down and change the sign, we just get 5 over 6. The equation of this line here must be y is equal 5 over 6, that's the slope, times x, plus some constant. To find this constant, we just put in an x and y we know. That's where knowing a point is important. So we put in this point, that's at 1 is the y part. 5 times minus 2 is minus 10 over 6 plus c. Rearrange this, we get c is equal, this is 6 over 6, or 6 over 6, put it in like that. Bring this over, we get a plus. 6 plus 10 is 16 over 6. Write the equation again, we get y is equal 5 over 6 x plus 16 over 6. That's the equation of that line. I realise I could change this to 8 over 3. I'll leave it as 16 over 6, so these are both 6's, even though it doesn't look like it. That's the equation of this line. At this point there is a couple of shortcuts, but if you didn't know those shortcuts, and they won't always be that easy, you might want to get the equation of this line. I've just wrote it down. You get it the same way. The slope of these two, which I think is just minus or plus 6 over 5, I think. Yeah, it would be, because the slope of this is actually minus 5 over 6, and the slope of the other one was plus 5 over 6, so they are just opposite of each other, not inverted though. So the other slope, the other equation would be y is equal minus 5 over 6 x, and I think minus 76 over 6. I hope that's correct anyway. That's the equation of these two lines. You could solve these two, put these two together to find this point of intersection. I didn't. That's why I only roughly did this one, and I might be wrong. I didn't. I stopped just at this point here because I knew something about this. I knew this was a flat line. So that means minus 5. I already knew part of this answer was minus 5 because of the symmetrical shape. If this is straight down, this must be straight across.
So once I got this equation, I knew y was equal to minus 5. So you could just put that in here. Minus 5 is the y, equals 5 over 6x plus 16 over 6. Multiply everyone by 6, you get minus 30 is equal 5x plus 16. Take 16 from both sides, we get minus 46 is equal 5x, or x is equal minus 46 over 5. So this point here is minus 46 over 5. I'll clear all this off and we'll get to trying to solve the area of this triangle. Now at this point you have a few options to try and find the area of this triangle here. One of those options is just you have 3 points. You have all 3 points. There's a way to use coordinate geometry to get the area of a triangle. You move this triangle so one of the points is the 0, 0. So basically add 2 to every x and take 1 away from every y. And then simply use the formula that's in your formula table. Boom, you have the area of the triangle. That's one way. Or you could get the length of each of these lines using the length formula. And there's another formula in your formula tables that if you have 3 lengths of a triangle, you can find the area of the triangle. That's also fine. I'm sure there's probably clever ways to get angles as well. But the main way I would do is I'd start thinking about the shape of this. First of all, the length of this guy is quite easy. It's a straight line. It's the distance between 1 and minus 11. So the length of that is just 12, first of all. And again, knowing that this is flat, what we really only need is the length here, from there to this line. The length from minus 2, this is the minus 2 line, to the minus 46 over 5. Like that, you can just think of that as a number if you want. 5 goes in 9 times and 0.2. So that's minus 9.2 and minus 2. So the height there is 7.2. Or if you'd rather, and I would, 36 over 5 is the length there. So the area of this triangle is, the easiest way I'd do it is A is equal to half. The perpendicular height is 36 over 5 times the base in this case would be 12. 2 goes into that. 6 times 36 is 216 over 5. That's the answer. I don't think you could divide that in, I'm not sure what it is decimal. I guess it goes in 43. Yeah, 43.2 would be in decimal places. Okay, that's one way to do it. That's a good way to do it because it's a very common way. Finding the equation of this line, finding the equation, having them meet. But there was a few shortcuts, which obviously I pointed out, the fact that it was symmetrical. There's more shortcuts. Let me draw this again in a simpler form. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Let me draw it like this. With maybe a line down through. This is actually a load of triangles and I think nearly all of them are symmetrical. Not symmetrical, they are similar. And that's because there's a right angle here and there's a right angle here. Let me name some of these angles. I'll make up a name for this one and call it A. So that's A, right angle, and this one up here will be B. Now what's interesting is this triangle here is A, right angle. So that means this one must be B as well. And the bottom row is identical as well. That means this one is B, right angle. Well, this one up here must be A. So we have a load of similar triangles. Let me just use these two up here, although there's a few options. I think you could use this one and the bigger one would be another good way to do it because that's a right angle, A and B as well. But I'll just use, I'll use these two triangles, this one and this one here. So right angle A and B, and this one's a right angle A and B. So you would have to rotate them around a bit
to have them line up with each other, and they're not going to be the same line. One's going to be bigger than the other, and we're going to use what we know about similar triangles. Well, first we know some numbers on this guy. The length from here to here, the length from here to here is just half of this, and as I said a few moments ago, that's 12. That's just the difference between 1 and minus 11. So this height here is just 6. The length from here to here is just between here, and that's the minus 2 line and the plus 3 line. So that distance is just 5. And then of course we also know this length is 6 because they're the same. They're the same length right there. Okay, similar triangles tell you that the same side divided by each other. So that'd be the length across from, which one we use? Oh, sorry, the length across from B. So the length across from B is 6, 6 here, and the length across from B on this triangle is 5. The ratio of those two, how much bigger this one is than this, that's what this is saying. 6 over 5 is how much bigger this triangle is than this. That means that must equal how much bigger this length is than this one here. So this length, let's just call it x for now. That'd be x divided by 6. So that's a very simple equation to get this length here. And remember, this length is just this length here. If we knew this, we could answer the question. And it's a very simple equation. Multiply both sides by 5. Multiply both sides by 6. We get 36 is equal 5x. Yeah, I'll write it in. And therefore x is equal 36 over 5, which was the very important number we took a few minutes to find earlier. So therefore this big triangle is just a half 36 over 5. That's this length by this base, which is once again 12. You would have had to find these 2 points either way, by the way. So I hope I don't gloss over that. And that's equal, just like we found earlier, 216 divided by 5. Okay, I thought it was a really interesting second way to answer the question. It was a bit cleverer, and you're rewarded by that cleverness by it being a lot shorter. But the first way I did is the way, if you think you might struggle in the exam, that is the way you should study. You should know that. If you've learned enough to do it the second way, brilliant, that's a reward for you. But the first way is the thing you should study and make sure you're able to do. Okay, if you have any follow-up questions about this question or anything in the exam, let me know in the comments below. I'll do my best to get back to you. Thanks for watching and have a great day. In question 9, we're given quite a common setup of a question. We have a triangle and we have a segment of a circle. Very regularly give you both of these. We have 2 formulas for them. We're going to use them both a lot, so I'll write them down here. I'll write the area of a triangle. That's equal to a half the 2 sides. In this case, they're equal because they're part of a circle. So that's r squared sine theta, I'll leave over here. And the area of a segment, I'll leave it a circle here. That's equal to a half r squared theta. In this case, the theta is actually an alpha. And the lengths involved are r. That's r and r. Part A, there's 2 quite different questions. They sort of change it up in the middle. Same shape each time. But for part A, they tell us that the area of the triangle is 4. So I'll write area, I'll keep the same notation. Area triangle equals 4. And the area of the segment is equal to, I'm failing to see it there, but I know it's there somewhere, 8 alpha. The area of the segment is 8 alpha. And they want you to find the area of the shaded region. This region in here. So that's clearly going to be the segment take away the triangle. So 8 alpha minus 4. That's going to be your answer. So you want to know what alpha is. So that's really what the question comes down to. Let's bring in our formulas to these numbers. So let's write a half r squared sine alpha, the triangle, well that's equal to 4. Let's bring in the other one, a half r squared alpha, that's equal to 8 alpha. We have 2 formulas and only 2 unknowns. We don't know r squared, we don't know alpha, we don't know r squared, we don't know alpha. We can solve this simultaneous equation, although it's a lot easier than that. These 2 alphas actually just cancel. This bottom row becomes or squared is equal 2 times 8, 16, or is equal to 4. Not plus or minus 4, because it's a real object, it's a length, can't have a minus length. So or is equal to 4. And alpha then, we could use whichever one we want. Let's use this one here. Oh sorry, no, alpha's gone in this one. We use this one here. Sine alpha is equal, let's see, 2 times this 4 is 8. And this is 4 squared, that's 16, so we'll divide over here. Sine alpha is 8 over 16, or sine alpha is equal to half. Let me do this pedantically. A sine looks like this. So when's it a half? The answer's here, here, all these places. Except in this question they did tell us, and it's from the picture, the answer is between 0 and 90 degrees. So that's in this little world here. Sorry, no, this should be right in the 0 line. So the only answer valid is here. Put that into a calculator. You'll get, or maybe you remember it, because we get sine a half, or sine an angle equals a half when the angle's 30 degrees, or pi over 6. But again, inverse sine of a half will give you that. Now that doesn't quite answer the question. They wanted to know the segment. Very common to have asked you that. So again, you could just get this area minus this area, but they've given you a lot more than that. They've told you most of the answers. The area of the segment is 8 alpha. The area of the triangle is 4. This minus this is your answer. You now know what alpha is. So this is 8 times pi over 6 minus 4. Let's see, that's 4 and 3. So 4 pi over 3 minus 4 is the exact answer they were looking for. You can't get that any neater, so that's fine. That's it for A. Let me clean off most of this bottom here and we'll do B.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
In part B, they tell us it is instead given. That means just forget a lot of what you know from the first part. That the length of BC, that's this line here, is 1 over the square root of 2 of OR. And they tell us the triangle, yeah, we write that the area of the triangle is still equal to 4. Now with this new information, find the area of the segment. So how do we go about doing this? You can maybe do somewhat the same. You could say a half or squared sine alpha is equal 4. You could get that one again, but they didn't tell you anything about the segment this time. So we can't get that second triangle from this information at least. The secret here is, well, it's hopefully clear that you need to use this. You need to use this new number that they gave you. So how do we do that? Hopefully what jumps out to you is we have a triangle. We have a length here, we have the angle across from it, we have the lengths of the sides. This is the cosine rule. The cosine rule tells us we have this length squared, 1 over the square root of 2 squared. That's 1 squared is 1, square root of 2 squared is 2, or squared is or squared. That'll be equal to this guy squared plus this one squared. Or squared plus or squared is 2 or squared. Then the cosine rule tells us to take away 2 times this by this. So 2 times or by or is or squared. Multiply that by cosine this angle. So that's cosine alpha. We have 2 equations, 2 unknowns, except just like the last time actually, one of the equations, everything cancels. Or squared just disappears out of this one. They all have the terms in it. So if we multiply everyone by 2, we clean this up a bit. On the left side we'll just have a 1. This will be a 4 minus 4 cosine alpha. We can just rearrange this and solve for alpha. Let's see, cosine alpha, if 4 comes over, it turns into a minus. So 1 minus 4 is minus 3. This minus 4 divides. That divides by minus 4. That's just 3 over 4. I won't draw the picture of cosine again. We solved this, it's between 0 and 90 degrees or pi over 2. Calculator will do this fine in one go. Put this into your calculator and let me just check my notes for the answer. You get 0.722734. I like to just take 5 or 6 digits when I'm in the middle of a question, or I like to keep it exact in my calculator usually. That's alpha. To answer this, if we have alpha and or, we'd be finished. I'm just stopped there for a second because I thought, there's probably a tricky way in this just to use 1 or 2 of them to find it. Let's just do it the dumb way. Find alpha, find or, and then find the area of the small bit. Okay, so or will, if we rearrange this one here, or squared is just equal 2 times 4 is 8 divided by sine alpha, or let's say you can get rid of the squared and put a square root in. We can put all this into a calculator. We will get or is equal, remember there's no plus or minus because it's a real number. Well, it's a positive number because it's an actual object. When I say real, I mean so this is 3.4777. Says going on like that. So to finish this question off, we need to find this area in here. Just like we've said before, we take the segment, take away the triangle. Here's the segment here, so that's a half. Instead of or, we know or, it's a 3.477. You don't have to write this out, your calculator can do all this for you. Instead of theta, this is a 0.722734. Take away this one, minus a half, or squared, let me just put in 3.5 for the moment, times, otherwise I'll run out of room, 0.72. We'll leave it in like that. Put this into your calculator. Certainly use all the digits here, at least 4 or 5 digits, because your final answer, you want 3 significant figures. Put all that in and we get, let me find here my notes. Yes, we get this answer here is 0.37068. They want 3 significant figures. That's this one here. This is closer to 10 than it is to 0. So 0.3701 is our final answer for question 9. Okay, if you have any follow-up questions or see any mistakes I made, let me know in the comments below. I'll do my best to get back to you. Thanks for watching and have a great day. In question 10, they give us 2 functions, fx and gx, and they want us to describe a sequence of transformations that gets this graph to look like this graph. Now this is it's an interesting question because they haven't shown us images of these graphs. They do actually in the next part, so we could sort of draw one of these, looks something like this, and I happen to know, it's okay if you don't, I happen to know what the square root of x looks like as well. That would look, it starts here and it would look something like that. Now don't worry if you can't do this because it doesn't really help much in the question. I'm just going to use it to describe a few things. Okay, so a step of transformations. When we move things on a picture, they do have a corresponding look in maths. For example, moving something to the left, which is going to have to be moved to the left and down. Moving something to the left is akin to adding something to x. Left is adding, take away is moving to the right. Yeah, that's a confusing way to say it. Going down is somewhat similar, except it's going down is adding to the y part, or going up is taking away from the y part. That might confuse some people because going down is taking away. A lot of people remember. But I'll show you what I mean to the y part in a moment because they're actually quite similar in different ways. Let's go through a transformation here. Y is equal square root of x. What needs to be done? First of all, we need to add something onto the x. So y is equal square root of x plus 2. Okay, we want to get this to look like that. Now, adding something onto the x is the same as moving to the left. That's how I'd write that. You can write that in English if you want, by the way. Move 2 to the left. But the right in maths term, it's just translating 2 to the left, which is the minus. And next thing I would like to, and I'll show you a few different orders to this in a moment. Next, I'm going to multiply everything by 3. This I would write as stretching, or I just write multiplying. I'll just write down multiply by 3. Stretching by a factor of 3 is how we'd usually write that in English. And actually, let me put them in translation. Apologies if I spelled this wrong. No, stretch. Yeah, apologies if the spelling's wrong. Stretch factor of 3. Next thing, I want to take 5 away. I'll write this twice because just to explain what I was talking about. We added to the x, moved it left. We add to the right, add to the y, moves it down. Equals 3 x plus 2. Although a lot of people just write that as taking away the function. Taking away goes down. I like to think of it as adding goes down because it then keeps it the same as the x. Adding to the x goes the wrong way. Adding to the y goes the wrong way. Left is usually the wrong way, down is usually the wrong way. That's I would say this last one would be 0 minus 5 is how we'd write that. That's moving downwards by 5. Again, that's a translation. This is full marks if you'd write something like this. But you have other options. You don't have to do it this way. Let me give you a couple of options over here. Actually, first let me write the one we did. We did to translate, the stretch, and the translate again. That was the option I did first. There's other ways to do it. You could have done the stretch first. You could have done multiplied by 3, and then you could have done both of these, like say minus 2 and minus 5. You could have done these in different orders. Hell, you could have even done these at the same time, minus 2 and minus 5. That would have been, all of these would be fine answers. The reason this multiply can happen before or after this 2 is because the stretching doesn't worry about the x part. The x happens in here. The y part happens out here. If we multiply this by 3, after I did this 5 part, we'd be in a bit of trouble. And that leads us to the other way we could do it. We could have moved 2 anytime, like I said, before or after. But if we want to move the y part before doing the stretching, we would have had to do something like this, 5 over 3 first, and then stretch. All of these are full marks as an answer. Okay, hopefully I've answered that. If you have follow-up questions, let me know. I'll clean this off and we'll move on to the next part.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
In part B, they give us a sketch of a GX. Now I have a problem with this question. I'll write what they've given us first. It looks fairly crappy, something like that. It barely looks like a little curve in it. And they want us to sketch the inverse of this. Really what they want you to do, because they even tell you to draw the relevant mirror line. An inverse happens when x and y change place, when x equals y. And when x equals y, that line looks like this. A straight line, a diagonal straight line through the middle. And to sketch the inverse, we just mirror it over here. This would be mirrored over here. The problem with what they drew us is I can barely tell there's a curve. And it's actually a wrong drawing. It's not a really good drawing. I guess it's maybe in their defense it doesn't go all the way to the edge. But that's not a really good defense because their own marking scheme, which this might have confused a lot of students, the answer they have in the marking scheme looks like this. Like this does not look like the drawing they gave you in the exam, whereas this is the correct one. So what they wanted to see, and I'm guessing the students might have been able to complain if they wanted this, what the exam should have done is drawn this line.
And then what they wanted to see is this dotted line in the middle and everything being mirrored. Instead of going straight down, this would be mirror up to here, this would mirror up to here. It would look more like a flat line like that. And it would curl like this. This curls away slightly, this curls away. This curls away a lot. That curls away a lot. That's full marks. From what they gave you, I would have just drawn something that seems to curl slightly. Like, that's all you can do. You take their drawing and you mirror it. They want this to be roughly the same distance. If you want, what you could do is actually draw a line, use your ruler, your set square, things like that. Get a few points and just get your compass and put the point over here and get a right angle. And just a few points, give you a few places to run off like that. But really a sketch, they just want it done quickly, roughly. They're looking for this center line being diagonal, and they're looking for the shape of this to be a mirror of the shape of that. I just think they did a really bad question. I think they drew that really bad. Okay, anyway, hopefully that answers part B. Let me clean it off and we'll do part C. You know, I probably don't need to clean it off. The rest of the questions should be quite quick. C is the only longish one, and we have a bit of room here. They want you to find the expression for the inverse of G. Now, how I like to do this, let's write G again, but instead of the G, I put a Y down. Y is equal 3 multiplied by X plus 2 minus 5. How you do the inverse is, we switch the places of the X and the Y. Some people like to do this at the end. I like to do it at the start. It really makes no difference. So if I switch their places, I get X is equal 3 times Y plus 2. Square root ends here, minus 5. Now what you need to do is rearrange this so we get Y equals. That will be the inverse. You don't have to switch this place, I suppose. It's perfectly fine just to rearrange it and get X equals, and then at the end we rewrite that as the more standard Y equals something in X. Okay, so let's rearrange this so Y is on its own. First thing, this guy dangling off the end here, let's add it to both sides. We get X plus 5 is equal. Yeah, I'll take my time doing this one. We'll be a little careful. I'll do each step. Next thing would be this multiply. That's the next part of the onion to unpeel. He's multiplying this side, so we divide the other side. X plus 5 divided by 3 is equal Y plus 2, square root of Y plus 2. Next we need to get rid of this square root. We square both sides. So we get X plus 5 over 3 squared is equal Y plus 2. Last thing to get rid of is this 2. We take it away from both sides. And I'll write the final answer over here is Y is equal X plus 5 over 3 squared take away 2. Sorry, maybe they'd take a mark away from me for that if I leave that as the final answer. What they really want to see is the final answer is, G of X. The inverse of G of X is equal to that. That's an expression for the inverse of G of X. The next few questions all get 1 mark, so you can answer these straight off the top of your head. I'm going to take a little bit of time to answer part D, so I've cleaned off an extra bit here. Part D is asking us about the range of the inverse of G, the range of this. Just to go back a few steps, let me write Gx. The range and the domain. The domain is what can go into Gx, and that's what they gave us here. The domain of this is X is bigger than or equal to minus 2. The range of Gx, we write that like this. Gx is what answers can get out. And we can see that from our drawing. The only answers that can get out are numbers above here, and this goes off forever. And this number would work out to be actually minus 2. We can see that a little clearer here. The smallest number that can go into this is minus 2, because this would be 0. 3 times 0 is 0. And then take away 5. Sorry, I said minus 2 over here. This would be minus 5, in fact, my bad. So what will come out of this question, what goes in is everything bigger than minus 2. What comes out of this, it has to be bigger than minus 5 and less than, I'll just write infinity, because you don't have to write that. Bigger than that is fine. That's what goes in and comes out. The inverse is the opposite. The domain of the G becomes the range of the inverse. The range of the g becomes the domain of the inverse. Basically, the answer to part D is simply the answer to part D is the inverse of g is just bigger than -2. It's because the range of this guy is the domain of that guy. So the g had a domain and a range. The inverse, let me write it over here. The inverse of this has a domain that's the same as this guy. That'd be x bigger than -5. And it has a range that's simply its domain, this one here. So this is bigger than -2. I just wrote that to the left, no real reason. Okay, hopefully that's clear. It's the domain and the range just switch places. That's all I wanted to explain there. Okay, I continue to be overconfident on how much I get to fit on my board. So let me just rub some of that off and we'll do E. In E, they want us to get the inverse of G of H of 4. They don't write in a bracket here, but I like to put this bracket in because I think it makes it clearer what's happening. What this is actually doing is we're putting something into H, and then the answer from this we're putting into the inverse of G. Let's make that clearer like this. Putting 4 into H is quite easy. Sorry, I never even wrote what H is. Let's do it up the top here. Hx, it was a very simple function. It was equal to x minus 2, and it only worked when x is bigger than or equal to 0. So if I put 4 in, that's simply 4 minus 2, which is simply equal to 2. So instead of the question they gave us, this is why we can do it with just one mark. Instead of this is identical to the inverse of g of 2. Instead of h4, it's just 2. h4 is equal to 2. And this is just equal to, I've rubbed off the function, haven't I? I better go to my notes. This is just equal to x, in this case 2, plus 5 over 3 squared minus 2. And that's just 2 plus 5 is 7. 7 over 3 squared, or 7 squared is 49. This is equal to 49. 3 squared is 9. Take away 2. 2 is the same as 18 over 9. So 49 take away 18 is 31. 31 over 9 is the answer to part E. Whenever you get a question like that, just do it in steps. You could have as many letters here as you want, as many of these functions as you want. You could have 5 of them. Just start at the back. Put in your own brackets each time. Yeah, for example, imagine you had f of g of h of k of 3. That's just, you do k of 3, whatever function k is, get that answer, put it into, oh, that was the wrong place, put the bracket. Get that answer and put it into h, then get that answer, put it into g, then get that answer, put it into f, and that's your final answer. It's actually quite a simple steps to do to answer this. Okay, for the final mark in this whole paper, they want you to explain why the composite function h of the inverse of g, opposite of this, why that doesn't work. H inverse g of x. Why does this, why can it not be formed? The answer comes down to its domains and its ranges. What comes out of this g1 is what, the inverse of g is what goes into h. And to go back to my example here, what came out of the k went into the h. What came out of the h went into the g. What came out of the g went into the f. What came out of the h went into the inverse g. What came out of the inverse g goes into the h. So we're talking domains and ranges here. What came out of the inverse g is its range, and that's, you just found that out over here. The range of gx, what comes out of that, is bigger than or equal to -2. All of this comes out of that. What's allowed to go into h is bigger than 0. That's a problem. They don't match. We cannot do this function because sometimes we will get -1 coming out of this inverse g. And -1 can't go into h. We're not allowed. So you could make a composite function of two functions that were nearly like this. If you made sure, if you told inverse of g, just be careful never to give me something less than 0, then you'd be fine. But you can't do that. To get a function of these two can't happen because you don't trust. You don't trust the inverse of g not to send out something that h will go haywire. Think of these as machines, a few machines in a row. You have to trust the previous machine won't break the next machine, and that's what happens here. It breaks the next machine. What do you write as the answer? The range of inverse g is not compatible with the domain of h. That'd be full marks there. Okay, that's it for question 10 and this whole paper. If you have any follow-up questions or anything you want to say in the comments, put them in the comments and I'll do my best to get back to you. Thanks for watching and have a great day.